Multiplying and dividing rational expressions uses the same technique of multiplying and dividing fractions. Our rational expressions are just fractions, and we can use the same techniques to multiply them. The first example I have here on the video is the fruit example, and I like to use this to show how we're actually able to cross out like pieces to make it simpler for us in our multiplication and dividing. So in my fruit example, I have a grape and an apple on top and a watermelon and pineapple on the bottom on the first, and then I have some fruit over in the other fraction. So these are being multiplied together, and when they're being multiplied together, I'm allowed to cancel like pieces that are diagonal from each other. So what I'm able to do is cancel the grape with the other grape. Those two were diagonal and they're the same, so I can cancel them. Another set of fruit that's diagonal that I can cancel is the watermelon. And then in addition to canceling diagonally, I'm able to cancel when something is same on the top and something is the same on the bottom. So these apples, since they're both on top and bottom, I can cancel them out. And when you're canceling things, it's 1 for 1. So there's one apple on the top, one on the bottom, so I can cancel them out. Now you take what's left and you combine it together. So the only thing left on the top is an apple. And whatever's left on the bottom, we're going to multiply together. So I have a pineapple and grapes. And this would be my answer. So we're going to do the first 6 problems as examples, and then you're going to finish the rest of the worksheet for homework, and then submit it on Classroom. The first step with multiplying and dividing rational expressions is to make sure that everything is factored. So in number 1, everything is factored, and we're going to look for like pieces, diagonal, or on top and bottom of each other. So the first thing I see is that there's a 10x squared and a 10x squared. One of them is on the top and one of them is on the bottom, so I'm able to cancel them out. I also see an x minus 9 binomial and an x minus 9 binomial diagonal from each other. So those can get canceled as well. The only thing left I have in my numerator is a 4, and the only thing I have left in my denominator is an x minus 6. Number 2 is also multiplication, and I'm going to factor everything I can. So I'm actually able to factor the numerator to x plus 10, x minus 5. As a reminder, we're looking for 2 numbers that multiply to negative 50 and add to 5. So some numbers that multiply to negative 50 are negative 10 and 5, negative 5 and 10, and when I add them, the pair of negative 5 and positive 10 add to give me that 5. And there are other pairs of numbers, but those are the first ones that popped into my head. I can't factor the x plus 10 in the bottom, so I'm just going to leave it. The 1 stays, and the x minus 4 can't be factored, so I'm going to leave it. Now we're going to look to see if there are any matching binomials or matching pieces, diagonal or top and bottom. There's an x plus 10 and an x plus 10. Those get canceled out. And there's nothing else that I'm able to cancel. When we're looking at binomials, you can't separate any of the letters or numbers, so I have to treat x minus 5 as a package deal. I can't separate them and cancel things away. So left up top is x minus 5 times 1, which is just x minus 5. And in the bottom, I just have x minus 4. And this is my final answer. Number 3 is also multiplication, so I'm going to go ahead and factor everything I possibly can. So I'm actually able to factor the numerator of the left fraction, and 6x and 24 have a common factor of 6. So I'm going to take that out, and I'm left with x plus 4. The denominator also shares a 6 with the 6x and the 54, so I can factor that out, and I'm left with x plus 9. The 8 stays the same, and the x plus 4 stays the same. Again, I'm looking for numbers or binomials that are diagonal or on top and bottom from each other that I can cancel. The first thing I see here are the 2 6s on the outside. Those get canceled away. And then the x plus 4 get canceled as well. So the only piece left is an 8 in the top and an x plus 9 in the bottom. And that's our final answer. Number 4 is division. And division is a little bit different because we have to use the rules that we do with fractions when we're dividing, and that's keep the first fraction the same. So I'm going to rewrite 7k minus 8 over k minus 5. I'm going to change the division sign to multiplication. And then I'm going to flip the second fraction around. So I'm going to change the bottom and the top. So k minus 2 over 7k minus 2. So we're multiplying, multiplication sign, by the reciprocal, and that's the flipping the fraction around. So we're going to go back to our same technique we were using with multiplication. Look for numbers or binomials that are diagonal that I can cancel, or top and bottom. I see 7s that can cancel. I also see a k minus 2 that can cancel. So the only thing left is a k minus 8 on the top and a k minus 5 in the bottom. Since those are not the same, we cannot cancel them. Here's our final answer. Number 5 is division. So we're going to use that keep, change, flip, or multiply by the reciprocal. So I'm going to keep my x plus 4. Keep my x plus 4 and 7x. I'm going to change the division to multiplication, and I'm going to flip my fraction around. The next thing I'm going to do is factor as much as I possibly can. So I'm actually not able to factor any pieces of the fraction on the left, but I am able to factor the numerator of the second. 3x and 6 both share 3, so I can factor that out, and I'm left with x minus 2. The denominator I'm able to factor to x plus 4, x minus 2. Looking for binomials or numbers or pieces, diagonal or top and bottom. Here I have x minus 2 and x minus 2. I also have an x plus 4 and an x plus 4. Left in the top is 3. Left in the bottom is 7x. I can't simplify that anymore. That's my answer. The last one we're going to do together is number 6. This is another division problem. So I'm going to use my keep, change, flip, keep the first fraction. Change the division sign to multiplication and flip the second fraction around. I'm now going to factor as much as I can. The 2b stays. I'm able to factor out a 6 So I have a 6, and I'm left with b plus 10 times the numerator of my second fraction. I'm also able to take out a 6, and I'm left with b plus 1. And then my denominator, I'm left with b plus 1 can't be factored. Now I'm looking for top, bottom, or diagonal that are the same that I can cancel. I see a 6 and a 6 that can cancel. And then I also have a b plus 1 and a b plus 1 that can cancel. Only thing left in the numerator is the 2b. Only thing left in the denominator is b plus 10. I can't simplify anymore. That's my final answer. Go ahead and work on the rest of the worksheet. Show your work, take a picture, and upload it to Google Classroom.